Hey, fellow problem solvers, Colfax Math here. Today we're working on math test success so that you could be as successful as possible on any standardized math exam. This is a really good course to help you study for the ASVAB military placement exam for both arithmetic reasoning and mathematical knowledge. My idea with this book was to have a 25-chapter book that'll walk you through all of the foundations of math so that you could be successful. The book's available on Amazon, or you could download it for free in mathtestsuccess.com. 25 chapters in the book, 25 corresponding videos. As you work your way through the book, I'll be there right next to you, working our way together through the book. You absolutely have to have paper and pencil out. You can't learn to juggle by watching me. You got to practice, and that's the same story with math. You have to do the problems to get good at them. So you need to be pausing the video, doing the work, taking the notes. So even if you don't have the book, which is free online, you still need a notebook out. You still need to pause the video and do the problems before I do them. All right, with that said, let's go ahead and get started with Chapter 18, Data Analysis and Statistics. This chapter is really a lot of vocabulary. You might know all of these things, but not recognize the words. So we're going to go over a quick overview, hopefully like a 10, 12-minute overview of basic statistics, a little bit of probability, and then there'll be a practice test at the end. So take these notes down in your book. The first three things you need to know for stats is the mean, median, and mode. The mean is the average. So the mean and the average mean the exact same thing. Usually the notation for mean or average is X bar. That just means you take all of the values, you add them up, and you divide by the number of values. The math notation for add all the values up is this Greek letter sigma. It is saying add all the values up, divide by the number of values. So X are your values, N is the number of values you have. Sigma means add them all up. X bar is the average. The median is the middle number. So you put your numbers in order. Let's say, I don't know, age of kids in a class, or 7, 8, 9. You put them in order. The median is the middle value. So the median here in this sample would be 8. And then let's say, let me add another one there. So that's 3. You'd pick the middle one. If there were 4 values, the middle value would be the average of the two middle ones. So if I have an even number of values, it would be 8.5. And then the mode is the most frequent. So I have 1 7, 1 8, but I have 2 9s. So the mode here would be 9. The mean here, I would add these 4 values up. 9 plus 9, 18. 18 and 8, 26. 26 and 7, 33. 33. So the sum of all these values is 33. So the average would be 33 divided by 4. Okay, here's another one. Here's an example problem right here. Pause the video and find the mean, median, mode of those. Unpause and we'll go over it. Okay, the mean of these 6 values is that plus that plus that plus that. All of them added up, divided by the number of values 6. These added up are 37. 37 divided by 6 is 6 and a little bit. There are 6 values. So the median is the average of the 2 middle ones. So the average is 5.5. And then there's 1 value of 4, 2 values of 5. So the mode is 5. Okay, move up here. Let's talk a little bit about probability. Probability is the likelihood of an event. All probabilities have to be between 0 and 100%. It is not 110% likely. That doesn't make sense. So all probabilities are between 0 and 1, meaning that if the probability is 0, it will never happen. And if the probability is 1, it'll definitely happen. Probability is always a fraction. So the probability of any event is equal to the number in the event over the number in the sample space. So as an example, let's say I have a 6-sided dice. What is the probability of rolling a 4? You were asking for the probability of rolling a 4. Well, there is only one 4 on that dice, so the number in the event is 1. How many possible outcomes are there? Well, it could come up a 1, a 2, a 3, a 4, a 5, a 6. So there are 6 outcomes. So the probability is 1 out of 6. You could leave it as a fraction, convert it to a decimal or a percent, but that answer, no matter what, has to be between 0 and 1. This one's a little trickier here. Go ahead and pause the video, see if you can figure out this problem here. Pause the video and we'll go over it. Okay, what is the probability of rolling a 10 when you roll 2 dice? Well, that first dice you could get a 1, 2, 3, 4, 5, or 6 on. 1, 2, 3, 4, 5, 6. So I could get a 1 and a 2. I could get a 2 and a 3 and a 2. So there are 36 possibilities. How many ways could I get a 10? I could get a 6 and a 4. I could get a 5 and a 5. I could get a 4 and a 6. Any other ways to get a 10? I don't think there are. So there's 1, 2, 3 out of 36. So there are 336 probability of throwing 2 dice and having them add up to a 10. Okay, example number 3. Go ahead and pause the video and try and do this. Unpause and we'll roll through it. What's the probability of drawing a red card from a standard deck of 52 cards? That 52 is telling you the total number of cards. So that has to be the bottom of the fraction, the sample space. How many of those cards are red? Well, half of them are red, or 26. That fraction reduces to 1/2. What's the probability of getting a red card? Well, it is 1 out of 2, 50%, or 0.5. Okay, let's take a look at this section right here, interpreting different types of graphs. First, we'll look at bar graphs. A bar graph, your independent variable is x. Going up is usually how often it occurs. And this could be, say, grades in a class, and there are 5 people with an F. There are 7 people with a D, 10 people with a C, 8 people with a B, and 6 people with an A. So that's kind of a standard bar graph. One thing to note on that bar graph is if it starts to approach this shape right here, like a bell, it is considered normally distributed. And we'll talk a little bit more about that. But a bar graph, histogram, some sort of value on the x, and usually a lot of times how often it occurs on the y-axis. Okay, after we have bar graphs, we have line graphs. And that could be, say, sales data over time, something like that. So on that line graph, your horizontal axis might be time. Your vertical axis, something like dollars or sales or units. And, it could be a line graph like this. And you're kind of looking for trends in there. If this were sales over time and you saw it go up and down and up and down, depending on what that time is, maybe this is December, and then this is June, like the 6 months, and then we're back at the December again, and you can see you have higher sales in December around Christmas time, lower sales in the summer. So a line graph like this is really good for showing trends. Usually the horizontal axis, or a lot of the time, the horizontal axis is time. It could be seconds, minutes, days, months, years, if you're looking at for longer span of trends. The next one is pie graphs, or a pie chart. Pie graph looks like this, and let's say this is your budget. 100% would be the full circle, and then I spend this much on gas, and that could be like 20%. And then this much on food, and that's maybe another 20%. And then this much right here could be, I don't know what else, entertainment or insurance. And insurance is maybe 8%. How much do you have left after you pay all those bills? Well, that's a really standard problem. You would add up what you have, 48%. The total is 100%. So you know after you pay your gas, your food, and your insurance, you're left with 52% to pay the rest. So every slice represents a portion of the whole. And then again, that whole circle adds up to 1 or 100%. A lot of times things like this, you might have a T chart or T bar to represent that. And you could say this is the item, and then this might be the dollars spent on it. So you could say gas, and that is $100. And then food, that's $100. So you could represent those things in a T-bar like that or a chart. Okay, let's scroll up here a little bit. Tables organize data in rows and columns. So you see a lot of tables that are spreadsheets. Going up and down like this are columns. I would think of like a big Greek building has columns in front. Going across are rows. And then these individual parts right here are called cells. Kind of a quick overview on some of the data that you might get asked in a standardized math question. A lot of this is just vocab, and you could figure some of it out once they give you that data. But we'll go over some practice problems and then the test. Let me move this up a little bit to frequency table. Frequency table is kind of showing you how often that thing occurred. So let's say our frequency table are grades, and then the frequency is how many people got that grade. So the frequency is a number of occurrences. So the grade is an A, and again, let's say 10 people got an A, B, 5 people got a B, a C, 10 people got a C, a D, 3 people got a D, and an F, 2 people got an F. This is the grade. It could be a window, 90 to 100%, or a lot of things. I add this whole column up. This is the total number of people who got grades, so 25, 28, 30. There are 30 people in this group that took that test. When you graph this out, you graph it out with that histogram or bar chart. I have 10 up high here, and then I have 5, and then 10 here, and then a 3, and then a 2. And I can see that does not approach that bell curve, so it is not normally distributed, and that's what this is talking about right here. So when it's symmetrical, that bar chart looks more like this, that your average is right in the middle, and then these kind of taper down. So this is a line of symmetry down the middle, meaning it would fold onto itself. If your bar chart and your data started to look like this, it would be normally distributed. And right, that frequency distribution would be something like 3, 5, 10, 5, 3. So it would go up to that high point and then back down and taper off. These are called tails on either end. If the data is heavily this way, so there's more data here, that would be called skewed left. And then the reverse of that would be skewed right. And then uniform data means that it's basically the same frequency, like 5, 5, 5, 5, 5. And then your bar chart would go pretty much, like this. Uniform data would kind of look like that. So it would not be normally distributed. Again, a lot of vocab, just trying to expose you to a lot of vocab. It's not a whole stats course, but just a quick recap on some of the key ideas in data and statistics. Okay, so let's get to some of these practice problems right here. This is really more about counting than anything. I have 20 students, and then here are their scores. So I like to cross these things out. I have a 6, a 7, an 8, a 9, and a 10. I think those are all of my scores. And then I want to create a frequency distribution, so I'm really just counting. So this is x, my value, whatever that data is, and then y is how often it occurs. So I'm going to count 6s first. 1, 2. Then I'm going to count 7s. There's one up here. 1, 2, 3, 4, 5. Then I count 8s. 1, 2, 3, 4, 5, 6. Count 9s. 1, 2, 3, 4, 5, 6. Then I count 10s, and there's only 1 10. My check is I add up the frequency. 12, 6 and 6, 19, 20. I have 20 values, so I know I didn't miss any. I have all my values there. Once I have this frequency distribution like this, or this frequency table, it's easier to find my mean, median, and mode. The mode, remember, is the most frequent value. This set of data is called bimodal. It has 2 modes. There are 6 values of 8 and 6 values of 9. So you would say it is bimodal. Both 8 and 9 are the most frequent. Okay, here's another couple of example problems here. Looking at, oops, I don't know what happened there. Okay, here's another example problem. Identify the range and outliers, if there are any. These are heights of a basketball team. What is the range of heights? So I look through here, and I find the tallest height, 78 inches, 6'6", and I subtract the lowest height, 65. So the range is 78 minus 65, or my range is 13 inches. It's quite a bit of range. Is there any potential outliers? Well, if I were to look at the average here, just to guess the average, it's like 72-ish, 73. This one's 7 below. This one's 5 above. I would say it is kind of a little bit of an outlier, but you could argue either way whether that 65 is an outlier. The way to do that is find the average and figure out the top value, how far away from the average it is, and the bottom value. And if there's a big discrepancy between the distance from the top value to the average and the low value to the average, then you call that an outlier. Okay, number 3, comparing data sets. Team A has an average score of 85. So I like to write these data points out like this. So we're talking about Team A has an average score of 85. Remember, X bar is average, and a range of 10. Team B has an average score of 82, pretty similar averages, but a range of 25. Compare the central tendency and the spread. So what you could say about this is Team A has an average and not very much spread on that average. The range is so small that all the values are between, say, 80 and 90. Here, the average is a little bit lower, but the range is really big. So you would say that the data is clustered pretty close to the average in A. However, in B, there's a large spread of data. This could be 94 to 70, right? No, 69 to 94. Really a big range of data here, because the highest value minus the lowest value is 25. Here, the range is only 10. Let's move this up a little bit. A data set of plant heights is described with a Okay, let's go ahead and All right, let's go ahead and take the test on chapter 18. Again, pause the video, do the test best you can. It's in the book. You could download that book for free, or you could buy it on Amazon. So let's go ahead and do this test. After you're done doing it, unpause the video and I'll run through it. Number one, find the mean, median, mode of this data. So first thing I do is I check if it's in order. The middle value would be the average of the two center values, right? Because there are an even number of values, so both these 5s are in the middle. So I'm going to average those two 5s to get a median of 5. The mode is the one that appears most frequently. Well, there's one value, but there are two values of 5. So the mode is also 5. Then to find the mean here, I need to add all those values up and divide by 6. 2 plus 3 is 5, plus 5 is 10, plus 5 is 15. 15 plus 6 is 21, plus 9 is 30. So the sum of all my values is equal to 30. Then I divide by the number of values I have. I have 6 values. 30 divided by 6 is equal to 5. So the mean is 5. That is just a coincidence that they all worked out to 5. That very rarely happens. Okay, problem number 2. What is the probability of flipping a coin and getting a heads? How many outcomes are there? There are only 2 outcomes. A head is one of those 2, and they are equally likely. So the probability of flipping a coin and getting a head is 1/2. Here's another question. What is the probability of flipping a coin twice and getting heads on both counts? Well, that one's a little trickier because I flipped that coin twice. I could either have heads, heads. I could have heads, tails, tails, heads, or tails, tails. There are 4 outcomes when I flip that coin twice. Was probably getting 2 heads in that case. It would be 1 out of 4. Problem number 3. What is the probability of drawing a king from a deck of 52 cards? You need to know that there's 4 kings, 4 out of the total cards of 52, and that fraction will reduce to 1 out of 13. Number 4, let me draw out the sample space. I have 3 red balls, 4 blue, 2 green. First thing I really need to do is figure out my sample space, my total number. 3 plus 4 is 7 plus 2 is 9. What is the probability of drawing a blue? Well, a blue, there are 4 out of the total of 9. Correct answer, 4/9. Okay, number 5, a pie chart shows a percentage of different colors of cars in a parking lot. If the chart shows 30% are red, what percent of the cars not red? So this is just saying if you know this thing adds up to 1. So if there are 30% are red, 70% or 0.7 are not red. Number 6, a survey asked 10 people about their favorite color. Responses were all of those colors there. Create a frequency table for the colors. So X is going to be the color, blue, red, green, blue I have, yellow, red I have, blue I have, green I have, blue I have, red I have. Okay, now I got to count them up. Here's 1 blue, 2 blues, 3 blues, 4 blues. So Y here is how often it occurs. Red, 1, 2, 3. Green, 1, 2. And then yellow is 1. I add this up to get 10. And I can see I have them all because it tells me there are 10 people. Okay, number 7, a set of test scores are these right here. What is the range? The range is the highest minus the lowest. So 95 minus 55 is equal to 40. So what is the range? The range is 40, but I could see this average is going to be pretty close to 70, and this 95 is far away from it. So 95 right here would be the outlier. So I call 95 right there the outlier. Okay, let me move this up a little bit. Number 8, the median income in a city is 50,000 and the range is 30,000. So I have two cities here, city X, where my median is 50,000 with a range of 30. And then I have a second city, Y, where the median is 52,000 and the range is 15. What can you say about the income and variability of income in those two cities? The average income is a little higher in city Y than it is in city X because the average or median is higher. However, there's a lot more variability in city X. These people are making, I would go half of that, say. I would go, the range here is 35 to 65, right? 15 below, 15 above. And here, the range is 45, let's just say 7.5 to 59. So on average, the median is higher here in city Y, but the range is higher here. So there's probably somebody making a lot, 65, and making a little. So there's a higher variability versus city Y. All right, well, hopefully that was helpful. If you're still here, well done. The harder you work, the more you practice, the better you're going to do on that standardized exam. It's always about practice. If you have any questions at all, please post them in the comments. I'll try and get to you as soon as I can. Think about joining the channel for additional videos and early access to the videos. And if you haven't bought the book, go ahead and buy it, or just go to mathtestsuccess.com and download it. But you really need paper and pencil out when you do these practice tests and you're learning math. The act of actually writing it out helps it stick in your brain. So thank you for watching.